Okay. Right. So this is tutorial 2, which is based on clustering. So the first 6 questions here are theory questions, right? So can you, I will give you like 15 minutes, students, or 18 minutes. Now it's 12:32. No, can you finish by 12:50 writing answers to these questions? Please start now. You have the slide in the courseware. So please start writing answers by in your own words. Okay. So don't repeat what's in the slide. That is not learning. Right. So learning is you understand the thing and you write it by your own words. Okay. So these are directly, if you understand the question, you can write. Okay. Right. Can you complete it within, let's say, next, I give until 12:50. Okay. Please start now. All right, students, shall we discuss the answers? Can someone tell me what is supervised learning? What is supervised learning? What is meant by supervised learning? Nobody knows what is meant by supervised learning. You can unmute your mic and tell the answer. That is fine. What do you mean by supervised learning? So tutorial is the time you answer the question, students. So I don't wish to give these answers for you to write down. That is not this kind. That kind of things you do in grade 3 or 4 in the school. Right? So that's not the way how our degree works. What is supervised learning? What's the difference between supervised and unsupervised? No one knows? Okay, what is meant by cluster analysis? Right. Yes, for the first question, supervised learning. Supervised learning is a machine learns from a data set which is having labels. Right. So we have already learned in the morning. So what you give in the data set is a label data set. You say, okay, if attributes are like this, outcome is this. So you give the target variable also, response variable, target variable, class, all those are synonymally used. So you give this data set which is having the class already. And it will look at and find out the patterns between the response and the other features, and it will develop a model which you can use to predict the unseen examples in the future. That is supervised learning. Unsupervised, what do you do? What do you do in unsupervised learning? You don't give the label data set, you just give the data set, and the machine is going to learn the underlying structures and patterns, and it's going to form partitions of different data. Based on their similarities, dissimilarities, it is going to partition, right? So example for supervised learning is the classification what we have learned today. Example for unsupervised is the clustering we have learned last week, right? What is meant by cluster analysis? What is meant by cluster analysis? Right, cluster analysis is the process of partitioning data into different partitions, right? Data objects you are partitioning. What is the goal? Very good. Process of partitioning set of data objects. Good. What is the goal is to maximize the similarity of objects within one cluster and maximize the dissimilarity of objects between different clusters, right? That is the goal. What is the characteristic that objects belong into the same cluster whole? They are similar to each other, right? They are similar to each other. Okay, so that is the second question. Good. So you have done some. What type of data processing would be required before cluster analysis? What do you think is good to do? Let's say you are doing k-means. What might be what might be the concerns you're having? What data processing you might have to do? Now, this is not directly from the slides, but you can, if you know what are the processors in data. Now, in the data pre-processing, we learned several things, right? Missing data, outliers, data transformation, and like transformation, we go binary encoding likewise. Then standardization, normalization, dimension reduction. So we did several of these, right? So what kind of data pre-processing would you use? What do you think are applicable? If we are using k-means, which are applicable? That you should know. Any idea? Any guess? Very good. K-means is, we discuss, it is sensitive to outliers. So you have to be concerned about outliers, and you might have to eliminate it. You might have to remove them, or you can bring them to the upper and lower bound that we discussed, right? And sometimes you might have to standardize columns, or sometimes you might have to eliminate the features, right? Unwanted ones you can remove, right? So those things you might have to do. Explain 3 application of cluster analysis. You can do many, right? You can use market segmentations. You can find out, we discussed in the class, I think, right? We can find out what are the people with the similar characteristics in social media. Likewise, there are examples, okay? We discuss it in the lecture, so we can refer to that. I can give you several examples, but only thing is you might not understand in the domain. People with same emotions, we have done a research like that. So people with image, we have got pictures of people, and people with the same emotions we have clustered. So then it will give you like, these people are very happy people, likewise it will cluster. Okay, right. Explain how the k-means is performed to identify clusters of observation. Tell me what are the input to k-means? What do you have to give to k-means? You have to obviously give the data set. What else? What do you mean by k there? K-means. What do you mean by k there? It should give you an indication. What is that? Apart from the data set, what do you input? You have to give the number of clusters now. You have to give you now what is the number of clusters you are expecting. Then, based on the number of clusters, what do you do? You have to define number of the centroids, right? So how does k-means is performed to identify clusters of observation? What do you do? Once the centroids are identified, you look at what are the points which are very closer to those centroids and assign them to clusters. So you might use Euclidean distance for that. Is it clear, students? That is what you do. Okay, explain how the k-means is performed to identify clusters of observation. So you input the data sets and the number of clusters you need. Based on the number of clusters you need, you have to set up the centroids. Then what you do is, each data point you compute the distance from centroids, and the nearest, you assign them to the nearest centroids. Afterwards, what do you do? What is the next step? After you assign the points, what do you do? After you assign the points, you recompute the center, right? You recompute the center. Then you redo the whole process again until all items are similar to each other in one cluster and dissimilar to those between different clusters. What are the limitations of k-means algorithm? Now, this is again textbook question. This is given in the slide. What is that? Limitations of k-means is what? There are several. It's directly from the slide. What are the limitations? One is you have to give the number of clusters. There's no point now in that case. So, but we found a remedy for that, right? You have to use the elbow method and find out the optimal number of clusters. Okay, that is one. You have to give the number of clusters. Other thing is what? It is sensitive to outliers, right? It can only identify sphere-shaped clusters. It can't identify arbitrary shaped clusters, and it can't identify clusters with different densities. Those are the limitations. Is it clear, students? Up to this point, is it clear? Any questions? Up to this point, is it clear? Right. Okay. Now, next question. Right. Good. Next question is something like this. So you can see here, there's a distance matrix given, right? And the coordinates are also given. There are 8 points. XY coordinates are given, right? So Euclidean distance matrix is also given. A1 to A2, what's the different distance? 25. Likewise, it's given, right? Again, it's given. Initial centroids are also given. Seeds are A1, A4, A7 are given. So that means there are 3 clusters. Let's say this is cluster 1 is center is A1, cluster 2 center is A4, cluster 3 center is A7, right? Now it's asking, identify clusters each observation belong to. For example, A2 point, where does it belong to? Is it belonging to clusters with A1, A4, A7? Finally, you have to calculate the new centers. Now we did exactly similar question in the class, right? So I have actually copied that matrix and the coordinates into this Excel sheet, and for your just for you make things easy for you, I have filled this one also. You know this, right? I hope you know this matrix A1 to A2, A1. Here what you have in this row is A1 to the distance to other points. So if you put it in this way, vertically also you get it in the same way, right? This 2572, 1350, 2572, 1350. Likewise, I have put the same thing. Why? Because then it's easier for you to read it. So now what are the centroids? Centroids are A1, A4, A7, right? Now, if cluster 1 is having A1, cluster 2 is having A4, cluster 3 is having A7, right? Now, quickly do this question. Where do you put A2? In cluster 1, 2, or 3? That's a very easy question. Where do you put A2? A2, where do you put? How do you know? We are doing the K-means, right? K-means means centers. These are centroids. So you get this allocated to the closest centroid. So where would you put it? With A1, A4, A7. A2. This is the A2 row. Cluster 1, 2, or 3. How do you know it? Now let's say centroids you know, right? A2, A1, A4, A7. Those are the centroids. Now get the distance from A2 to A1. A2 to A1 is 25, square root of 25. It's not simplified, right? A2 to A4 is square root of 18. Right? A2 to A7 is square root of 10. Right? Square root of 10. Right? So now where would you put it? In which cluster? Cluster 1, 2, or 3? Which is it nearest to? Which centroid is it nearest to? That is the cluster you are going to put it. So where would you put A2? A2 should go to which cluster? You don't have to simplify this, right? What is the one giving the lowest distance? Lowest distance is square root of 10. Square root of 10 means it is closest to A7. That means it should go to cluster 3. So A2 goes here. Yes. Right. Now do the rest and compute the center. I will give you 5 minutes to put the where it is belonging to. Okay, 5 minutes. Huh? Nothing more than that. Okay, are you done, students? What are the items in cluster 1? Cluster 1, how many points are there? How many points are there in cluster 1? Data points, like you have A1 to A8, no? How many points are there? Cluster 2, how many points? What are the points? Cluster 2, what are the points? These are very easy questions. Huh? You have to just look at the distance and compare. What are the points in cluster 2? Do you need more time to do this? You have only 5 points, 4 points to look at now. Already 4 are there in the table in this categorization. Just 3, 5, 6, 8. Where is point A3? A3 should be where? Where is A3? A3 is in which cluster? A3 is in cluster 2. So if you highlight this, if I can't actually highlight this. So if you highlight, let's say I can draw it now. So let's say the ones we are concerned of is this one, this column, and what's the other one? A7, this column. Right, now if you take A3, what is the one which is having lower one? A3, 72, 25, 53. So you are going to put it in cluster 2, right? So here, it's going to be in this is going to be in cluster A3 is going to be here. Okay, one. A3 is going to be here. A5, okay, it's gone now. I forgot, I just 50. Okay, where should A5 go? Which cluster? I should ask from you first. Where should A5 go? A5 also go to cluster 2. Good. A6? A6, which cluster? A6 also go to cluster 2. Right? What about A8? A8 should go to where? A8 also go to cluster. Very good. A8 is also going to be cluster 2, right? Okay. So now you are asking, now let's say C1, C2, and C3. I'm giving names for the points, the centroids. Now, what is the centroid for cluster 1? Let's say it is C1. What is the XY coordinates for cluster 1? Cluster 1, what is the centroid? After this computation, after you run this, what is cluster 1? What is cluster 1? Cluster 1 centroid. That is easy now. You have only A1 there. So that means you can directly put the A1's coordinate, 2 and 10. What about this one, C3? What's the coordinate? XY coordinate. A2 is cluster 3 is having A2 and A7. 2 points. What do you do? What do you do? You have to add up the x coordinate and divide by the number of points. Number of points is 2, no? Now, if you add A2's x coordinate is 2. This is 1. 2 plus 1 is 3. 3 divided by 2. You get 1.5. Is that clear to everybody? X coordinate is 1.5. Is it clear to everybody? Is it clear to everybody? X coordinate of the cluster 3 is 1.5. Is that clear? Right. Can you tell me the y coordinate for cluster 3? Y coordinate for cluster 3 is what? What is the y coordinate for cluster 3? Just add up the y coordinate and divide by 5. Divide by 2. Yes, it is 3.5. 5 plus 2, that is 7. 7 divided by 2 is 3.5. Now this one, again easy one. You have 5 points. So add up the x coordinate and divide by 5. You have to consider cluster. This one, 3, 4, 5, 6, and 8. Tell me what's the x coordinate. It is 6. Y coordinate is Add up the x1. 8 plus 5 is 13 plus 7, 20, 26. And 26 plus 4 is 30. 30 divided by 5 is 6. Correct. Y coordinate is? Y coordinate is what? Add the y coordinate and divide by 5. Y coordinates of these 5 points. Again, you get 6, isn't it? 4 plus 8, 12. 12 plus 5, 17. 17 plus 4, 21. 21 plus 9, 30. 30 divided by 5, again 6. So that's the centroid. Is that clear, students? Is the question clear? Is it clear to you? Right, good. Now the next one, students, next question. So we have done this one. Next question is, here distance matrix is given. You have to identify the cluster where it belongs to. That is the question we just did. Now the next one, the distance matrix is not given. The coordinates of the points are given. Using Euclidean distance, develop the distance matrix for observation. So you have to do that first. Okay, can you do that? Okay, just let me unshare for a moment. Right, I will share back. Right, here you are. So you have here, I hope you can see it. So you have 8 points, and the coordinates are given. Now, first thing you have to do is you have to complete the distance matrix, right? Distance matrix, right? So here it said, identify the cluster. Suppose that the initial seeds, that is centers, are x3, x4, and x6. x3, x4, and x6. That means we are going to have at the end 3 clusters. Let's name them as cluster 1, cluster 2, and cluster 3. This is x3, x4, and what's the other one? x6, no? x6. Yeah, x6. Now, students, you have to find the rest. Now you have x1, right? x1 you have, x2 you have to find. Then x3 and 4 you don't need. 5 you need, 7 you need, 8 you need. So complete the distance matrix first. Now you don't have to complete the distance matrix for everything. So let's do it like this. Now you want the distance from x2, no? x1. So that means fill this row. Row wise, can you fill it? Or row wise or column wise. You don't need to complete the distance from 3, 4, 6. Maybe not. 3, 4, 6, no need. x1 column fill, x2 column fill, x1, x2, x5, x7, x8. Those columns only, if you fill, you can manage. Okay. So you know the distance, how to get this distance, right? So if you have point A and point B, A is x1 and x2, B is this is x1 and y1. Okay. x1 and y1. This is x2 and y2. What would you do to get the distance? Using Euclidean distance, you have to x1 and x2 get the subtract and get the square, plus y coordinate get the difference and square, and you have to get the square root of this, right? You don't have to simplify this, okay? So for example, if I'm computing distance to this one, how would I do this? x1 to x2, x1 to x2, what do I do? Here the another coordinates, okay? Right? So the distance between x1 and x2, sorry, yes, x1 and x2, what do you do? Points now. So you have to get 2 minus 2 x coordinate difference square and y coordinate 8 minus 5. 8 minus 5. So here you get 0. Here you get 3. 3 to the square of 3 is 9. So you already know what is square root of 9, but don't put it like that. Just put it as square root of 9. Then you can put it here as well. Right? Likewise, only fill these columns. If you want row wise or column wise, you can do. I think it will be easier for you to do row wise. So do these rows x1, x2, x5, x7, x8. Those rows only fill. We are running out of time also, students. So quickly do it. You don't have to even do all of this. You have to find the distance of the centroid. So if you want to find out where to put x2, you have to compute the distance from, even this is not needed. What do you have to find out? x2 to distance to 3, 4 and 6. Okay, do that and tell me where to put it. x2 to distance to centroid only. If you do it, that is sufficient. Tell me what's the distance. These three distances, what is it? You don't give me you don't have to give me the square root. Just tell 9, 10, 7, no, so whatever thing. I will put it as square roots. X1 also you need. These values you need. X1 also you need. Actually, you should have only these values. I'm circling, but you are circling that. And these values. If you feel this much, you can get the answer. You don't have to fill the whole matrix. Tell me what's the distance? This one, and this one. What are these? This and this. Three, 4, 6. What's the distance from x1? x3, x4, and x6. What are the distance from x3 to okay, is it 37, 9, and 32? I will put your answer. I hope it's correct. So it is 37. Okay, I will delete this one. It's disturbing. 37, 37, 9, and 32. 37, 9, and 32. Is it? Is that correct? Others? Is it correct? Is it correct? Is this value correct? 37, 9 and 32. So in this case, X1 should go to cluster 2, isn't it? X1 should go to cluster 2. Others, is it clear? Okay, then tell me what are these points? These 3 points, what are the values? These three have the circled points, what are the distances? What are the distances? We have only 5 minutes to run, so hurry up. This is 37 is correct. Okay. Next one is 10, 18, 17. Is it? Ten, 18, 17. Is it? So others, you also have to do it. Huh? Only one person is doing it, it seems. 10, 18, 17. Is this correct? 10, 18, 17. Is it? I'm just writing your answers, okay? Right, good. Then where would you put it? Where's the cluster? Which cluster are you going to put it? X2 is going with which? Cluster 1, 2, 3. X2 is going in which cluster? Cluster 1, right? Cluster 1. So X2 goes here. Right. Now compute these three. We have 4 more minutes to compute these three values. What are these three values? X5 to X3, X5 to X3 if you get 37, 29, 2. Is it? Others, quick. Sorry, 37. What's the other one? 37, 29 and 2. Is this correct, others? 5 to 6, obviously it is 1 and 1. Yes, it is square root of 2. It's correct. 5 to 4. It is 7, 2, 4 and 25. Yeah, it is 29. It's correct. This one, 5 to 3. 5 to 3 is 36 and 37. Correct. So it should be in cluster 3, isn't it? So X5 should go to cluster 3. Can we do the next two also quickly? So that at least we do that part of the question. X6, X7. X3 to X7. It's 53. Is it 53? Square root of 53, is it? This one? Did I make a mistake or is it 53? 53, okay, very good. 53, 25 and 4. 53, 25 and 4. Others? Is this correct? 7 and what is our 7 and 6? 7 and 6, the difference is 2, 4. Yes, this is correct. 4 and 7. What's the difference? 4 and 7. 4 and 7. It is 25, correct. So where would it go? X7 also should go to cluster 3. Light. Last one also can we do before we finish off? Last one, what are the distances? This is 13, is it? Then the other, what's the next cluster? 4. This is 2. Just check it, okay? This is 13, is it? Is my computation correct? Is it 13, 13 and 2? Or did I make a mistake? I'm not quite sure whether I think I did a mistake. No? Cluster 3, this might be wrong. Or is it correct? This is wrong, no? This one is wrong. It's X3. No, I think I took it something else. This is wrong. Other 2, is it correct? 2 and 13 should be correct, right? Yes, it is 34. 34. Yeah, this I think I'm mistaken. Okay, 34. That means the lowest one is this one, cluster 2. So this one, X8 should go to cluster 2. Others, do you agree? Only one student is working out, it seems. Right. So the next question, next part is identify the clusters is the first part. Then next part is calculate the centers. Now you know the centers, the not the centers. You know the coordinates. Please do it. Now here, what you should do is here there are 2 points, 3 points, and 3 points. Here, adapt the x coordinate and y coordinate and divide by 2. Here, adapt the x coordinate and y coordinate, divide by 3. Same here. In that way, you can get the centroid. Is it clear, students? Is it clear? So we will have to stop here because we are running out of time. All right. Okay. Then we will stop here, students, and we'll meet after the supplementary exam for the lectures. And we will continue the lecture series.